In this video, I'm going to show you how to solve log equations. It's going to be a couple of steps here to do the process. The first step is always get the log by itself. So all we want is a log expression all by itself. So if there's anything in front or behind it, undo it using your PEMDAS or SADMEP. Because we're solving, we do PEMDAS backwards. Take care of subtraction and addition first, then get rid of any division or multiplication, and then the rest I'll show you how to use your log properties to deal with. So that's the first step. I mean, the second step is to use your log properties, which should be obvious, I guess, if we're dealing with logs. Let's just get into an example here. So first, I need my log expression by itself, meaning I just want a log with a base and a number next to it. This all counts as one expression, so you can think of it as one big number there. So really what I have is I have this 5 in front. That's what I need to undo. 5 is being multiplied to our log expression. So to undo it, if I divide both sides of my equation by 5, I undo that 5 there. So now we have our log expression all by itself here. It's equal to 2. And we can use our rolling method or our circle method to evaluate. So I take the base to the power on the other side of the equal sign. So 3 squared is the same or equal to 3x plus 12. Simplify and solve for x. So we got 3 squared, that's 9. We got 3x plus 12. So just normal algebra rules. Again, we're using SADMEP to solve. Get rid of our addition or subtraction first. Get rid of that 12 by subtracting it from both sides. So now we got, 9 minus 12 is negative 3 equal to 3x. That's all that's left. To get x by itself, divide by 3. And our final solution is x is negative 1. So even though it looked really complicated, it wasn't all that bad if you just follow these little steps here. Let's get the log by itself. And once you have a log by itself, you can use your circle or roll method to evaluate and solve for x. Let's try another one. So because this is in exponent form, we don't have to convert it to exponent form yet. All we have to do is get that exponent by itself. So if we could just get this little portion by itself, we should be able to solve it. We're going to use our change of base property eventually here. So let's see what we can do. I need to get rid of this 40 in the front here. So if I divide both sides by 40, I should be able to get my exponent by itself here. What we got here? 6. Alright. Do that division easier if you just ignore those and do 24 divided by 4, you get 6. Now I want to be able to bring my exponent down because I don't know how to solve things that are up here in the exponent realm. In order to do that, if I use an inverse property, meaning how do I get rid of this e here and cancel that so that it drops this down? Well, the inverse of e is a natural log. So if I take the natural log of both sides, that's kind of a tricky step because you just have to know your properties of logs in order to do it. Then what happens here is the natural log of e becomes 1, and so this all goes away. And I'm just left with this. It's got dropped down. And so over here I have the natural log of 6. Let's write it in the correct form then. And now it's just calculator work. The natural log of 6 can be found using your calculator. To solve for x, we got to divide both sides by 6/10 or 0.6. So really from here it's just your calculator doing the job. Take the natural log of 6 and divide that answer by 0.6. And you should get approximately 2.98. So kind of a different type of problem there, but still using log properties to solve. Again, this step right here, the trickier one, got to know your inverse properties. How do you get rid of an e? Use your natural log. Okay, let's look at a different type of problem. Same kind of concept though. A little bit more challenging. So again, now we're looking at another exponent problem here. And I know that I said at the beginning we were dealing with log equations, but they are really similar. And we kind of use both properties. We use exponential properties and log properties to solve both types of equations. So I'm kind of putting everything together in this video. We got to get this exponent by itself. So we're going to add 3, get rid of that 3 first. So now we got 13 on the other side. And again, we're going to use that same property. If I want to undo something, you can use a natural log as well. I mean a common log as well as a natural log. It doesn't matter. You're going to get the same answer out of both. I don't know, for some reason I like natural logs, so I'm going to take the natural log of both sides. That will allow me to drop this exponent down because now I can use my exponential property. And if you don't know what I'm talking about, I would suggest that you watch my video on quotient, exponent, and product properties in order to understand. But anytime I have a log with an exponent, I'm allowed to take that exponent and just put it at the front of the log. So now I got 4x minus 7 is being multiplied by the natural log of 5. And it's equal to the natural log of 13. So really what's happening on the left is 4x is being distributed, and so is negative 7, or the natural log of 5 is being distributed to both of those if you want to think about it that way. So really what we get is 4x times the natural log of 5, I'm just distributing, minus 7 times the natural log of 5 equals the natural log of 13 over on the other side. And I want to solve for x. So how could I get rid of everything around x? Well, let's see. If I add this, 7 times the natural log of 5 to both sides. Let me rewrite that better. 7 times the natural log. 7 times the natural log of 5. That gets rid of it on this side. So now I'm almost there. I almost got x by itself. Everything over here is being multiplied. This is 4 times x and times the natural log of 5. So I can undo each of those multiplications using division and just keep x there. So I want to divide by 4, and I also want to divide by the natural log of 5. That'll leave x alone over there. If I do that to both sides, then I've gotten rid of this, I've gotten rid of this. So I have x all by itself. I have x equals whatever this long expression over here equals. And really all you got to do is use your calculator to figure it out. Punch in the natural log of 13, add that to whatever the natural log of 5 times 7 is, and then divide that whole thing by 4 times the natural log of 5. And eventually you will find that x is approximately 2.15. So again, this last step is just a lot of calculator pushing, a lot of button pushing. So good luck being able to do problems like that. That's kind of the harder end of the spectrum there, a little bit trickier, a lot going on there. So yeah, good luck solving log expressions. I guess we got a little bit of time here. Let's do one more. Let's do one that's just a little bit easier, so you can feel better about yourself. If I want to solve, let's solve for x. Going back to ones that are just logs here. We could do it. Let's do a 7 there and an 11 over here. Alright, we want to get our log by itself. So this 7 is really cramping our style. Actually, we can make it even a little bit more complicated. Let's put everything all together there. So this 7 is being added to our log expression. We got to get rid of that. This 2 is being multiplied to our log expression. We got to get rid of that. And remember, when we solve expressions or solve for a variable or solve for x, we want to use SADMAP, do PEMDAS backwards. So we're going to take care of this addition first. We're going to subtract 7 first. Let's make this a, yeah, that's fine. So we get 4 there. So we're good so far. We want to undo this multiplication here. We want to divide both sides by 2. So that gives us log base 3 of x minus 1 equals 2. Now we finally have our log expression all by itself. So we can use our circle method to evaluate, roll it around here. We got 3 squared equals x minus 1. Simplify a little bit. 3 squared is 9 equals x plus 1, or x minus 1, sorry. Add 1 to both sides to get x by itself. So x is finally 10. Alright. So that should be good. You should feel better about yourself about that one. That's a little bit easier there. So good luck solving log expressions. Again, just get the log by itself, undo everything around it, and then use your log properties to solve for x. Good luck.